So let's talk about the caliper tool. We're going to talk about where caliper, as well as geometry tools, may be part of the Vision solution. We're going to actually create and configure our caliper tool, and our caliper is going to be looking for edges. It's an edge detection tool. Okay, we're going to set up certain parameters, and set up sorting, which this is where it makes it tough to be able to find where those edges are. So let's talk about the caliper. So what a caliper is looking for edge or edge pairs, and it's going to report that edge location, where it found those edges to be, as well as any distances between edge pairs if that's what you're using. So some caliper application is great for gauging. It's going to measure what the distance between two of your edges are. Also, it's great for fixturing. That's because PatMax can take some time. Edges run in less than a millisecond. You know, when you start putting it on a major processor like the PCs and stuff, now we're talking like down in the order of like, I don't know, 50 microseconds. They are screaming fast tools. So what we want to do is we want to measure from one side to the other side. Yeah, I think my arrow's off a little bit, but from one side to the other side of this particular part. So what we want to do is we want to use a caliper tool. Now with a caliper tool, you're going to have a couple of different, like a filled-in arrow as well as an open arrow on it. And we want to put it past the edges that we're looking for. I always see people try to set it really, really tight. That's asking for trouble. Go past your edges because you want to pick up the edges in case things move a little bit. So of course, like with the other tools, you would set up your region of interest underneath your current dot input image. And then we need to think about what does it look like? So when we're looking at the actual tool for this, you're going to notice that you have a filled in arrow. That's your scan direction. That's the direction that it's looking for the edges. Okay, so it's scanning in this direction. Then you have a projection direction. Because what ends up happening behind the scenes is that it projects all your pixels down into a one-dimensional array. And it's that one-dimensional array, it looks for what the first derivative of it. It looks for the change inside your edge on it. You have your skew handle, and of course you have some rotation. So we want to make sure that our scan direction is going to go perpendicular to the edge that we're looking for, because it needs to look for that edge. Our projection direction is going to go parallel to the edge that we're looking for. We give you some skew because there might be times that you have it coming off of a straight edge there, but they're skewed off, but yet you still want to measure them in parallel type ways, so you can skew for that particular angle range. Now the next thing you have to do is you need to set up the parameters. So in order to set the parameters up correctly, you have to understand how the tool works. So how does it work? Well, the first thing you need to do is you need to choose, are you looking for a single edge or an edge pair? Then you need to choose its polarity. Now remember, it's going in the scan direction. So if you're looking for that first edge, are we going dark to light, light to dark, or either? If I chose edge pair, what's that second edge doing? Once again, scan direction. What is that second edge doing? And then also what that pair width is. Right now, since we're pulling in a pixel image, this is in pixels. So you're kind of dialing it in to say about how many pixels am I expecting it to be between my edges for me to consider this an edge pair. So let's say that this was my image, these two squares, and I made my edge tool really big. Okay, this is not normally how I would do it, but let's say I made it really big. So what it's going to do is it's going to average this first column of pixels all the way down so that it has an average grayscale value. Then it's going to take the second column, average it, third, average it, and so forth. So by me taking in all this excess white underneath this could throw off what my average grayscale value is. So this is why I said I would not make it that thick. I'd make it much thinner. But now I have a one-dimensional projection, okay, just a 1D projection. Then what it does, it goes into this edge filtering. And the edge filtering is where I start getting my first derivative coming from this. Now don't freak out. We're not going to force you with the calculus on it. But let me talk about a little bit about what it's doing. Notice that it shows you your gradient of your pixels here. So this is adding up to what these appear up here. So notice, you know, your dark ones are going to appear lower, your brighter ones are going to appear brighter. Okay? But what it's looking for right here is anytime you make a change. So anytime I make a change, I'm going to have a little peak. So I made my change right around here as one change, and then my next change is right around here. That's my other change. That's how I'm finding what my edge is. And whether it's positive or negative depends on whether I'm going dark to light or light to dark. If I'm going dark to light, that's going to be a positive peak. If I'm going light to dark, this is going to be a negative peak. So that's all that it does, is it says what polarity you're at. Then it does this filtering. Okay, so you're putting in place this edge filter. And how it works is you have your projection image, and that's what the grayscale values are sitting here. And then you have this little edge filter. And this comes along. So what happens is it says, okay, I have these three numbers, and I'm going to look at these three numbers here. So I'm going to times this by this, times this by this, times this by this, and then add them together. Well, since I have all zeros, it's going to come to 0. Then I move it over 1. So this is going to get times by this is going to get times by this is going to be times by this, and then I'm going to add them together. So all I have is a 5. So 5 goes in here. Move it over 1 more. This by this, this by this, this by this. So now I only have a 10. Move it over 1 more. -5, 0, 15. So now I have 10. So it keeps going over, and it's going to come up with these numbers. So now this is where my peak is coming from. This is that first derivative that it's doing. So it's finding out where I have changes coming in. I will only have a peak if I am going from light to dark or dark to light. If there is no change in the color, then it's 0. Nothing changes. Okay? Now you would choose a very small filter width if you have a very sharp edge that is changing quickly. It's basically asking you how many pixels does it take to get from light to dark or dark to light. So if I have a nice sharp one, 2 pixels, 3 pixels, fine. If I have a more dulling one, like it's going off of a rounded edge, then I would increase that. In this case, this is going like 1, 2, 3, 4, 5. So 5 would probably give me a better result. So notice that for this one, if I have my width at 2, bam, I got a nice big peak. But if I go over this one, it doesn't pick it up that well. Notice that as I increase it to 6, notice that that basically takes out this peak, but it now centers on this one. So this is your way to try to dial it in. Do I have a slowly transitioning edge, or do I have a very quick edge? So you go in and you say, what's your threshold? Your threshold is how many grayscales does it need to be before I decide that this is indeed something that could be a peak, something that I care about, light to dark transition. Then you have your maximum results. How many are you looking for? And then you have your filter half size. That's that edge. You know, do I care about whether it's 2? Do I care about whether it's 4? You just need to know how many pixels does it take to get from dark to light or light to dark. So there's your contrast threshold. So if I didn't have any changes, it would stay right here. But I might have some garbage, some background noise, and so you notice that it's all over the place. So what I might want to do is if there's only certain peaks that I care about, I want to increase that threshold so I get rid of some of the noise. So I get rid of some of that background thing. Sometimes you're not going to be able to. But sometimes you can just put that in, you only find the edges that you want, and you're good to go. So like I said, and then you say how many results you're looking for, and it's going to give you out what the results are. So you run it. You have your choice of what graphics you want to show. So some of the graphics is your edge found. So it actually shows you in green little lines where your edge was. Then you can also say, hey, I want to show my affine transform. So it's showing you what the 1D projection ended up being. This is what the grayscale values were, what the 1D projection was, and where were its peaks. And you should see the peaks are wherever you're changing color. Okay, wherever it's changing from light to dark or dark to light. And then you get your results. So you'll have something like score. Score is going to be based off of whatever your scoring functions that you use. By default, it's contrast. Okay? Then you have edge 0 and edge 1 if you're using edge pairs. Edge 0 will be the first one. Edge 1 is the second edge. Measured width, if you're using edge pairs, what's the distance between those two? Then you also have this concept of position. And position is going to be based off the center of your region. So if it's a negative position, it means that you're off to the left of that center point. If it's a positive position, you're off to the right. Just gives you an idea of where inside the region of interest is that. XY location is the actual XY location that you're finding those edges at. And then your function scores. Like I said, by default, it's going to be your contrast. What did your contrast come up with? But there's going to be times when you can't find those edges that you want, or you need them to be in a certain order and they're not going in that order. So what you need to do is you need to use scoring functions. And what they're going to do is they're going to allow for you to set up some type of graph that allows for you to score these. This is where it gets tough. Now I should first ask, how many of people have used Caliper and Insight? Because that is where this is coming from. Now I find that Insight was actually easier how they did it than VisionPro does, but VisionPro expands this. Okay, there's a lot more you can do with the VisionPro one. So you're going to end up getting something that looks like a graph, and you're going to choose what's considered their edge versus what's not. Now anytime that you're up high, so y0, anytime that's 1, it means that is indeed an edge. Anytime that it's 0, it means this is not an edge. So you're setting up your criteria between x0 and x1, as well as xc, to say, where are my edges falling? Now don't freak out yet. Okay? Just stay with me on this. So whatever is x0 will be mapped to y0. Whatever is x1 will be mapped to y1. Okay? And then you always have this xc, and I like saying xc is kind of going to infinity. It's where it just stops looking. It doesn't go any further from there. x0, or I should say x1 is always between x0 and xc. Always between it. Okay? So you just need to set it up so that you're deciding what is a good edge and what's a bad edge. So in this case, we're saying that anything below x0 is going to be considered edge. Anything above it is not. I know. And the fact that we haven't said what this thing is where it gets even tougher. So let's talk contrast, just pixel values. That's what it's going to look like. So, how close are you to, do you have a higher contrast versus lower contrast? Usually higher contrast means better edge. So it's going to have a higher score. Then we have straddle. Straddle is just saying if you're using edge pairs that the edge pairs, one is on one side of the center point, the other one's on the other side of the center point. So it's either going to straddle or it's not. Then we have size. And the size is going to be the width between the edges. So you have size difference normalized. So we're taking a look at what's the full field of view that we're looking for, minus what size did we find, divided by what we expect it to be. Okay? So the full width. The fact that we have it differential means that we don't care. Whether it's positive or negative, we're looking on both sides. Same thing, absolute value. If we just want it normalized, we just take the size and divide it by what we expect the size to be. Okay? And then we can also say size difference normalized asymmetrical. So instead of using the absolute values, we're just saying, hey, if it's negative, then we know that it's negative. If it's positive, then we know, that it's gone over it versus going under it. So our W is not so much, I know it says the width of the edge model, but it's the width of the ideal measurement. That's what we're going by. That's your ideal measurement, is how close you are to that ideal measurement. Then there's position, where it actually lands inside your region of interest. So you can have it just be the absolute position. Doesn't matter where it's left or right, but the one that's closest to where the center is. Position normalized. That means take the whole region that you're looking at and divide it by, divide what you found the position to be by the whole region. You can have it position negative, which means no absolute value. It can be a negative value. Or you can also have it normalized negative. Once again, that we're looking at what it found it to be divided by the whole area. But once again, it can be normalized. So we know whether it's left or right. So what they're going to do is all these, whatever you have set up for your positions or for your scoring, it's going to take all these functions and it's going to normalize them. Okay, it's going to give you a final score for it. And it's going to geometrically average them. So it's going to start playing off of each other and see which one's going to come up the highest for you. Okay, and then it's going to order them afterwards. So let's try this. Don't freak yet. I'm telling you, it does look very, very scary to first look at it. It does. But just bear with it and think about what it's asking. Okay? Like I said, don't freak yet. It was my first inclination as well. So let me go ahead. First thing I want to do is I'm going to flip this over. And I'm going to look In this case, I'm going to look for these white lines here. You can do it either the black squares or the white lines. I'm going to go with the white lines. I'm going to say that each of those is an edge pair. And I want to position them, order them according to position. So let me stop this first and add a caliper tool. So call a caliper tool, drop this in. Now, where should my input image come from? I have fixture and I have image source. The fixture, exactly, because I want it to stay with my part. So I'm going to go ahead and say fixture, and I'm going to run it once. So now I want to go in and I want to set it up. So let's open up our caliper tool. Okay. And what I want to do, now notice I have a filled in arrow and I have an open arrow. Remember, my filled in arrow is my scan direction. So I want my scan direction to be perpendicular to the edges that I'm looking for. So what I'm going to do is I'm going to choose on this and I'm going to rotate it. Okay? Then what I want to do is I want to move this, and I'm just going to make it a very narrow little slice right down the middle of my little lenses here. Okay? Why do I not want to make it fat like this? Right, because I have this, well, in our case right here, it's a vertical thing, but it would be horizontal within the region of interest. This is going to throw some bogus numbers into it. Why take those in if I don't have to? So that's why I want to make it a little bit smaller than it. Now notice I am going past my edges up here. Okay? I want to go past them. Please don't sit there and I see people, oh, I'm right there. No, you're asking for trouble. Go past your edges. Okay? So what it's going to do is it's going to go in the scan direction and it's going to look for edges. Beautiful. So now am I looking for a single edge or an edge pair? Edge pair. Okay. So if I'm looking for an edge pair and I'm going down with my direction, what is the polarity of my first edge? Exactly, dark to light. And what's my polarity of my second edge? Light to dark, right. So I'm going dark to light here and light to dark here. Okay, that's the edge pair I'm looking for. Okay, and what I'm going to do is I'm just going to run it real quick. I have my pair width set to 10, and oh, how many am I looking for? I'm looking for 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm looking for 9. So let me set this at 9. My pixel half size is pretty sharp edges, so 2 should be fine. And my contrast threshold of 5, it works. So let me go ahead and run it. And if I take a look at my results, this is what it's showing me. So if I look at my input image, it's showing me this is where it found it to be. Now if I click on it, notice this is where it found the first one to be. The second one's down here. Third is in the center someplace. Fourth, fifth, accordingly. Now my width is actually around 4, not 10. So notice how my score here is only at like 0.4, 0.5. That's because I'm asking for my edge width to be 10, and they're truly around 3 and 4. Okay? So I could go back into here in my settings. Instead of saying 10, say 4, run it again, and notice how my results have gone up. Okay? They've gone up to 0.9 because I've made it closer to be what they really are. The 10 was getting too far away. Okay? So now since I made it closer to 4, then yes, this actually now it's going to say this one's my lower one. This is my next one because it's going to be how close are you to 4? That's what it's looking for. So the one that's only 2.88, my narrowest one, is going to have the lowest score because it's the furthest away from my ideal value of 4. So far, so good? So by default, whenever you do edge pairs, it's going to take your size as your default. Now what I want to do now is I want to order them top to bottom. That's the order I want to do them because right now it's not. How is it ordering them? By size. So I want to add top to bottom, but I still want to keep the size because that's what's detailing which one are my edge pairs. Now I want to put them in some type of positional order. So let me go to scoring. So right now my scoring is saying my size differential normalized. All that it's saying is my size. Okay? And if I take a look at it, it's saying that, okay, X0 is 0 and x1 is 1. So it's saying that the closer I am to what my size is here, which is 4, versus what it's saying here, which is 1. Oh, because it's dividing them. So the closer I am to 1, because it's taking what the actual size should be minus what it found it to be, dividing by what it actually should be. Okay? So if it's really close to it, it's going to be very close to 1. Okay? If it's not, it's going to be away from that. Or I'm sorry, I should actually be near 0 because I'm minus them from each other. So if I take the actual one, minus it from what it found, I should be almost at 0. Okay? So the closer I am to 0, the better it is. The further I'm away from 0, the worse it's going to be.
And what is it? Yeah, it's closer to 0?
What is closer to 0 is I'm taking what I expect my width to be minus what it found my width to be.
Right, but what is that called? Is that?
Oh, my x0 is what that ends up being.
Okay.
Is that the number.
And that's because it's the differential norm we're seeing here that it's plotting?
Yes, that's what it's saying. So we're saying that the closer I am, because I've stated x0 would be 0, the closer I am to x0, I'm sorry, the closer I am to x0 or to the number 0, the more that it's going to be an edge. As I start getting to the number 1, it drops off from being an edge. Okay, drops it quickly. And then xc is just 1, 2. It means it doesn't look past a 1. So as I start pushing it too far away from it, it says, no, I have no idea what you're doing. Forget it. You're too far away from it. So if you're more than double or whatever the thing is, it doesn't even look at it because now you're above 1. So that still takes care of, that's my size. So now I need to get position. So in order to get position, I need to add new, and I have all these selections. Now I'm going to go with negative. Okay, just the position negative. The reason is because remember, anything to the right of the window, or in our case, anything to the top is going to be a negative value. Anything to the bottom is going to be a positive value, right? And I want to label it from negative all the way up to positive. So I don't want an absolute value. If I do the absolute value of it, just say position, then it's going to be wherever I am around the center of the region, and I don't want that. So it's going to go outside in instead of what I want to do. I want to label it down.
And our region is what?
Our region is our region of interest. That's our whole region. So right now it's saying, okay, x0 is negative 100. So it picks about what your region had been, and it knows what the position to one side. So if I'm all the way over to my, in this case, my top, that's going to be negative 100. If I'm all the way down to the bottom, that's going to be positive 100. Okay? So right now I have it set up that if I'm at negative 100, this is going to give me a much higher score than if I'm at positive 100. Okay? That's all it's saying. It's just saying I'm saying that the closer I am to negative 100, the higher my score is. Okay? So if I go ahead and leave this on and run it, notice now if I choose this, it's going to be my uppermost one. Okay? If I choose the next one, it's the next one down. And the next one, and so on, and so forth. And it starts cranking down until it gets a pretty low score, but that's at the very bottom, because the further I go away from negative 100, the more it's going to drop.
Just for ordering?
And that helps me do the ordering. So now I've just gone top to bottom.
And we did not turn off our differential norm.
Nope, because that's what decided what my edge pairs were. So then I took my edge pairs and I now ordered them in order.
So these rules are building on each other. Okay.
Because all the scores are going to be geometrically averaged to each other. So it does go in there and it shows you your scoring function. So scoring function 0, that's your the one that's doing the size. Those were the scores from 0. And then scoring function 1, which was your position negative, that shows you what your scoring functions were there. And then they geometrically average them together to get your final score.
Which is the beginning score.
Yes. Yes. So every time you add a score, it's going to give you a separate scoring function. Now,
can you go over the values of the scoring pad?
okay, so for this one right here, okay, I have my x0 equals negative 100. So here's x0. So negative 100 means positioned all the way over to the left of it. In our case, it's the top, but it's all the way over to the left. My x1 is 100, and the reason they pick those up is because that region happens to be about 200 pixels. If I had a larger region, it would choose better numbers. XC, it just means it stops looking then. I could pull this in if I wanted to, and just pull it into 100 as well, and it just stops looking. You can see a much more graduated scale. Okay? So far, so good? Then we have what Y0 and Y1 is. Now remember, when Y0, or when something is 1, it means it's the edge. And Y0 is what's determining, is going along with X0. So I'm saying that if I'm at negative 1, I'm in negative 100, my value is going to be close to 1. So here's my negative 100, so here's 1. Means it definitely is an edge. Then Y1 is going to be associated with X1, which is 0. So as I get further away from that point, it's going to start dropping. If I take a look at my size difference, oh, sorry, let me go back to my size difference. Oh, so here's my position based off the center point, negative to positive, and my size differential. And this one, it's saying, okay, x0 is 0, and in our case, that means I am almost exactly what I had said the width measurement should be, because it's the width minus your distance. So if they're the same, I'm going to get almost a 0 value. As I start getting almost twice as much as what it should be, I'm going to get like a 1 stating there or higher, and so it's going to drop down to be no edge at all. So that's how it's trying to differentiate that. So far, so good? Now, let me just show you this only because I think it's worth showing. Let's say that I want to order in the other direction. Okay? So if I want to order in the other direction, I need to choose x0 being greater than xc. It's going to reverse it. But here's where things start getting tough. What it does is it doesn't change x1. So what I need to do is I need to go in there and put a negative here, because I need to get x1 to then go from 100 down to negative 100. Okay, so now I'm going in this direction. So if I run this and I take a look at my results, notice now I'm going from bottom to top. Okay. The only thing with that is it didn't change what your x1 should be, so if you didn't notice that, your results get thrown all over the place. Okay, so you just have to remember to adjust your x1.
That still left y1 negative 100. Why is it changing? Right?
Y1 is,
I'm sorry.
XC is negative 100. Right, because you can't go past that side of it, really. Like, I don't know why it sets it at 100,000 to begin with, because your region's not 100,000 big. But yeah, it's not going to let you go past the XC. So let's just keep going with our class. So with the geometry tools, we actually break them into a couple of different categories. We break them into creation, finding and fitting, intersection, and measurement. So if I want to create something like, maybe I want to create a circle, create an ellipse, do something like that, then I can actually go into geometry creation, which will allow for me to create a shape there. This might be a shape that then I will use with something else. Like, I want to measure the distance between this shape that I've created and another line that's been there. So it's allowing us to create some type of shape and place that on our application. Now we also have finding and fitting tools. This is in case we're looking for something, like if we're looking for a circle and we find the points going around the circle, and that we can say, hey, I want the best fit circle, or I just want to find where that circle is. So we're going to be given a region, and within there it's going to find either a circle or a line for us. Or it's going to give us the best fit, which the best fit, the major difference is the best fit says, hey, I might have some extraneous points. I'm going to throw those out so that I get the best ones that's going to denote what my circle is going to be. Then we have the intersection tools. I bet you can't guess what they do. They intersect. So in case you're trying to get a point, so you might have drawn a circle, you might have drawn an ellipse or something, and then you have perhaps a line coming from, let's say it might be from your edge tool, your caliper tool. And so now you want to know, where do they intersect? So therefore you can extrapolate from the segment that the caliper gives you, you can extrapolate the line from that. So do you want to know where circles intersect? Do you want to know where a segment intersects a circle? Do you want to know where two segments will intersect itself so that you can come back with a point that might be used for some other type application? And finally, measurement tools. So now that you have some segments or lines or circles, now you can say, well, what's the distance between them? Am I trying to measure an angle? So with angles, I can either use line, line, or point, point. Otherwise, with all my distance, any of the different shapes and stuff, I can see, well, where is the distance between one shape compared to another? So from yesterday, like we said, the caliper can be used to find a single edge or edge pairs. The scoring functions will allow for you to try to find some other type lines, like maybe put them in a certain order or give a different weighting to a particular variable within those lines that you want that's more important to you. And geometry tools will help you bring out features and measurements based on lines and angles coming from some of your application. So let's try this. Let's do the geometry one. So I've already started up VisionPro again, and I checked to make sure it was running. If you had left it on last night, there is a chance that you might not be getting an image. That's because what happens is the PC goes into sleep mode, shuts down the network card, which then shuts down the driver to VisionPro, and now it's not connected to the camera. Easiest way around it, shut down VisionPro, open it back up again, you're good to go. Just make sure that you had saved your application before you did that. So now we see that I have my application here. What I want to do is let me dig into this, and you will notice that I have my connector on the back. What I want to do is I want to find that angle at the top of my connector there, because if I turn this over, you'll notice that it's actually skewed. So I want to see what's going on with that angle. Okay? So in order to do that, I'm going to do some line finding tools. So let me go down underneath my program there. I'm going to open up my tools, and I'm going to go underneath the geometry finding and fitting tools. I'm going to get the cog find line tool, and I'm going to drop that in. Okay. Now my find line tool, what is the input image I should be using for it?
The fixturing.
Yep, I want to use the fixturing because I want it to move with my part. Otherwise, it's going to start trying to grab anything that it can get. So I'm going to go with the fixture tool, run it once, just so I have an image in there. And now let's go into the find line tool itself. So you'll notice over here that it's giving me this little line here with a bunch of, anyone can guess what the tool this is? Calipers. It has given me an array of calipers. So I have the choice how many calipers I want to be there. So if I want more calipers because I'm trying to pick up more points there, I can increase the amount of calipers. Okay? If I want less, I can decrease it. Now they have this search length. And my search length, if I increase it, you'll notice that it's increasing the distance of this. So let's just kick it up to, like, if I say 50, notice it's gotten longer. So it's looking across that direction. Now notice the big arrow here. Okay? That's your scan direction. It's looking right now from top to bottom for my edge. So what I can do here is I can move this up so that I'm coming from one side of this line here to the other side. Okay? Dig into this a little bit more so you can see what's going on. Now, yes, I can try to put it right on the line here, but if it's not a big deal. I can kind of leave it right here. Now, I want to bring this in just a little bit, and you'll notice that my edges are kind of pushing into each other. I can reduce the projection length. If I reduce the projection length, it goes down in decimal values. Let me reduce the projection length to maybe like 5. Notice that now they've gotten a little bit smaller. Okay, just giving me a little bit of distance in there. What I want to do is I want to find this line, this top line right here. Okay, so I have some calipers sitting here looking top to bottom trying to find that line. Let me go to my caliper settings next to do the next thing I need. So if I go to caliper settings, it's saying, okay, are you looking for a single edge or an edge pair? Well, what am I looking for? Actually, I'm looking for a single edge. Yep, just one edge. So if I'm looking for one edge and I'm going top to bottom, what is the polarity of this line that I'm looking for? Dark to light, exactly. Can anyone guess why I don't want to leave it at any polarity? It could potentially, and what might happen is I might have a point here, point here, point here, and it could throw off where it's finding that line, okay? So I want to make sure I'm always finding it along the top. So if I run this once and take a look at my input image here, let me dig in so you can see what's going on. Come on. There we go. Notice, there it is. It's finding me my line right there. That's my line. Okay? So it has created a line for me. So that has found the top line along my connector. Now we want to add another line. So let me go ahead and close this tool. I'm going to go up to my tool set again, go underneath the geometry, finding and fitting, do the cog fine line again, drop that right underneath the one that I've just had. Once again, where do I want to pull my input image from? The fixture, exactly. Run it once. And now let's go in and set up this tool. This one, I am going to take it and I want to put this right along, well, I can make it a little bit bigger here. This along here and this along this. I don't need to make it just this short little segment up there. I could use the whole back of the camera because the back of the camera is going to stay parallel. Okay, it's going to stay one consistent number. So by maybe making it a little bit bigger along the back, what do you think this is going to benefit me? Or how do you think this is going to benefit me? That what? It would be more accurate. Instead of me just trying to pick up, a couple points right here, instead I'm arbitrarily kind of picking some up as they go down, okay? Because that's going to keep, remember, once again, that's not bending, that's going to stay one line. If I wanted to increase or reduce the number of calipers, I can take care of that. If I need to swap direction, because right now I'm scanning right to left, if I want to swap direction, I can either grab this and turn it around, there we go, I can turn it around this way, so I can do it visually, or I can also push the little button that says swap direction, and it changes my arrow, okay? So now I have it so it's going left to right. Now I'm purposely going to grab my little plus arrow here and I'm going to make it a little bit longer, okay? Because notice I could be picking up these edges as well, and I'm purposely doing that. Let me go to caliper settings. So I'm still trying to find a single edge here, but what's my polarity of this line? Light to dark, exactly. I'm going left to right. I made them a little bit longer, but notice that's not going to throw me off here because I'm always going light to dark, so that's what it's looking for, is just my light to dark. I'm going to run this once, check to see what the results are, and you'll notice that the results is that it finds my line coming down the back of my camera. So far, so good? Yes, no, maybe so? Notice that it has caliper scoring in here. So if you needed to find special edges and everything, that is built into this. So this is just an array of calipers is what it's doing, an array of calipers. So now it comes down to the final part where I'm trying to find the angle between the two lines. And I'm going to go ahead and switch this from my output image to my fixture image because that's what's showing me my actual lines here. So I now need to go back into my toolbox, go underneath the geometry and measurement tools, find angle, line, and drop that in. Now it's asking for an input image. Where does it get the input image from? It's 50-50 chance. Fixture, exactly. It needs to come from the same image of the tools that it's being used with, okay? Then it's asking us line A, okay? So you'll notice that each of your fine line tools, they have a get line and a get line segment. Can anyone tell me the difference between a line and a segment? A segment has a finite distance. And your finite distance is going to happen to be where you started it to where you ended it. That's the actual segment. But for us to do an angle, we have to assume it's a line, not a segment. So when it's saying line A, if I just right click on it, I could say link from, and it's telling me, well, you can get your fine line tool 1 or 2. Well, I'm going to go ahead and stay with 1 because A, 1 makes sense to me. You know, B, 2 makes sense to me. So when I go to B, I'm going to say link from, fine line tool 2, grab that, and then run it. So when I run it, you'll notice it gives me a little cross on the screen. It shows me what those lines are. Okay? If I go into the tool itself, you'll notice that if I go to results, it tells me how many degrees it is. Okay? So let me go ahead and have this run. If I take this and turn this over, notice that if I go to the bad one, it gives me 91 degrees. Now, depending on which line you've stated first, it could be negative versus positive. But another thing that changes it is where your origin point is. Okay? So my origin point, because it's at 0, it does dictate kind of where things are going from at that point.
So if I got negative 1.5 is my angle, what?
Negative 1.5.
For some
I'm guessing it's radians is what you're using, not degrees. Oh, you bring up a good point. If you take a look down and you hover over the actual thing, it's always in radians. And we're going to actually take care of that in scripting.
Okay, good.
Because
Say,
the
yeah, the results show me 90, so negative 90.
inside the actual form, it actually allows for you to do the conversion. You can say radians or to degrees, so it lets you go back and forth. But the information coming out of the tool itself only gives it in radians. So part of our scripting is going to be to take that, change it to degrees, because that's what us in the U.S. use mostly. We don't care about radians.
What pure numbers in America?
We're still in feet. What do you expect? Okay. I'll give you some times to put that together, and then we will go on to the next section.